Okay, this is for mathematical methods. It's involving sketching this cosine curve that's had one dilation, two dilations, and a sideways movement. Okay, just to find the normal things for graphs, I need to find the x and y intercepts first. And of course, I've got a restricted domain here. So if I do y of 0, that's going to be 2 cos of 3 times negative pi on 4, which is 2 cos of negative 3 pi on 4. Where is negative 3 pi on 4? It's around here in the third quadrant, all stations 2 Coolaroo. That's going to be the same as the negative cos of pi on 4, which is 2 times minus root 2 on 2, which is negative root 2. So that's my y-intercept, negative root 2. If I'm finding the endpoints, then I want y of minus pi, which will be 2 cos of 3 minus pi on 4, which is 2 cos of 3 times, so if I'm doing minus pi on 4, there is minus pi, there's minus pi on 4. It's the same as being in the second quadrant. So it's also going to be 2 cos of, 3 times minus 5 pi on 4, which is 2 cos of minus 15 pi on 4. Where is minus 15 pi on 4? That's minus 4, minus 8, minus 12, minus 15. That's going to be in the second quadrant as well. So 2, and in the second quadrant, it's going to be negative, and it's going to be negative root 2 on 2, which is also negative root 2. And if I place in the endpoint, which is 2 pi, I'm looking at y of 2 pi is going to be 2 cos of 3, 2 pi minus pi on 4, which is 2 cos of 3, 8, so that's 8 pi minus pi on 4, which is 7 pi on 4. 2 times the cos of 3 lots of 7 pi on 4, which is 2 lots of the cos of 21 pi on 4. Where is 21 pi on 4? There's 4, there's 8, there's 12, there's 16, there's 20. 21 pi on 4 is down here, which is 2 times negative root 2 on 2, which is negative root 2. So my endpoints and my y-intercept are all negative root 2. What are going to be my x-intercepts? Okay, so to find where the x-intercepts are equal to 0, so 0 equals 2 cos of 3 times x minus pi on 4, with 0 equals the cos of 3 x minus pi on 4. Okay, what are the values of cos that give me a 0? Well, pi on 2 is one of them, and 3 pi on 2. So my answers are going to be pi on 2, 3 pi on 2, 5 pi on 2, negative pi on 2, etc. So my angle, which is 3x minus pi on 4, equals a range of numbers. So let's say I've got minus pi on 2, I've got pi on 2, I've got 3 pi on 2, and I've got 5 pi on 2. So divide by 3, that's going to give me minus pi on 6. And I might actually go back and include the one before this one as well. So minus 3 pi on 2 as well, and that will be minus 3 pi on 6, pi on 6, 3 pi on 6, and 5 pi on 6. And that's what x minus pi on 4 is. And then I've got x equals minus pi on 2 plus pi on 4, and minus pi on 6 plus pi on 4, and pi on 6 plus pi on 4, and pi on 2 plus pi on 4, 5 pi on 6, 5 pi on 6 plus pi on 4. So this will be minus pi on 2, so that's minus pi on 4. And this one is all on 12, and that will be minus 2 pi plus 3 pi. And this is also over 12, and that will be 2 pi plus 3 pi. And this will be 3 pi on 4. And this one will be all on 12 for double that, so 10 pi plus 3 pi is 13 pi on 12. 3 pi on 4, which is 9 pi on 12. 5 pi on 12. Pi on 12 minus 3 pi on 12 is what x equals. Now I can see that we're increasing by 4 pi on 12. So 17 pi on 12 will also be another one. And 21 pi on 12 will also be another one. And since I'm going up to 2 pi, I'll include my 21 pi on 12 because 24 pi on 12 is going to be the end. So 21 pi on 12 is my last x-intercept. 17 pi on 12, 13 pi on 12, and going back in the opposite direction, I'm going to have minus 7 pi on 12 also, but minus 11 pi on 12. So we've got a lot of x-intercepts here. So minus 11 pi on 12, minus 7 pi on 12, minus 3 pi on 12, pi on 12, 5 pi on 12, 9 pi on 12, 13, 17, and 21 pi on 12. 1, 2, 3, 4, 5, 6, 7, 8, 9 x